Have you ever wondered how we actually teach a computer to, say, recognize your face in a photo? Or how it understands the text in a book? Or picks up on these insanely complex patterns from just a bunch of raw data? I mean, it kind of sounds like absolute magic, right? But it's not. It's the very real, very fascinating world of deep learning. And today we're going to unlock exactly how this is done. The secret sauce? It's a wildly powerful tool called PyTorch. Okay, let's just dive right in. We're going to trace the exact step-by-step path of how a machine actually learns something. We always start with raw data. Then we pack that data into these special containers called tensors. Next, we feed those tensors straight into a neural network. After that, the network goes through this phase called training. That's where it literally learns from its mistakes. And finally, we get a prediction. Now look, if all these terms sound completely made up to you right now, do not worry. By the end of this explainer, you're going to understand every single piece of this puzzle. So, welcome. I am absolutely thrilled to be your mentor for this explainer today as we dive into what is PyTorch, a complete beginner's guide. My whole goal here is to make this super approachable. So seriously, take a deep breath, maybe grab a cup of coffee or tea, and let's demystify AI together. You definitely do not need a math PhD for this. You just need a little bit of curiosity. All right, here is our roadmap for today. Number 1, welcome to PyTorch. 2, setup and capabilities. 3, tensors, the raw materials. 4, building and training networks. And 5, acceleration and summary. Okay, let's get into it. Section 1, welcome to PyTorch. So at its absolute core, PyTorch is a deep learning framework for Python. But what does that actually mean for us? Well, it's basically a super popular, fully open source tool that developers and researchers everywhere use to build and train AI models. It hands you all the pre-built tools you need. That way, you aren't stuck programming the unbelievably complex, heavy math of artificial intelligence totally from scratch. I absolutely love this analogy because it makes it all so clear. I want you to picture PyTorch as a physical workshop. PyTorch is the room itself, the space where all the magic comes together. Tensors? Those are your raw materials, like the lumber and steel you haul into the shop. The neural network layers are your building blocks. And training? Training is just the teaching process. You're the master craftsman, guiding the tools until the final piece is absolutely perfect. So whenever you hear some crazy AI jargon, just ground it right back to this simple workshop idea. Moving right along to Section 2, setup and capabilities. Honestly, the sheer variety of what you can build in this workshop is mind-blowing. PyTorch is just so incredibly flexible. It's used to build image recognition systems, like the facial ID on your smartphone. It powers the natural language processing behind modern chatbots. It's huge in computer vision for self-driving cars. It runs generative AI that makes those stunning pieces of digital art. And it even powers the recommendation systems that mysteriously know exactly what movie you want to watch next. It is literally everywhere. Okay, so how do we actually get the keys to the workshop? Usually, right from your command line, you'd run a super simple installation command, something like pip install torch vision. But putting my mentor hat on for a second, this exact command totally depends on your specific setup. It depends on your operating system and especially on your hardware, like whether you're running a standard processor or a beefy graphics card. So you'll always want to head over to the official PyTorch website to grab the exact right command for your specific machine. All right, once it is installed, we need to actually open our toolkit inside Python. And we do that just by typing import torch. Super easy. And right alongside it, we'll usually type import torch.nn as nn. Now, this torch.nn module is absolutely critical. The nn just stands for neural network. You can think of this as the specific drawer in our workshop that holds all of our pre-made, ready-to-go neural network blocks. Which brings us to Section 3, tensors, the raw materials. Now please, do not let the word tensor intimidate you. A tensor is literally just a multidimensional numerical container. That's the whole secret. It's just a box that holds numbers. Inside PyTorch, we use these tensors to hold our raw input data, the internal dials and parameters of our model, and the final outputs. Seriously, if you can wrap your head around a spreadsheet holding numbers, you already understand what a tensor is. Now, these tensors come in a few different sizes, which we call their shape. Think of them kind of like physical Lego blocks. Just a single number on its own, like the number 5, is called a scalar. A single row, or line of numbers, is a vector. A grid of numbers, kind of like that flat spreadsheet we just talked about, is a matrix. And if you start stacking those spreadsheets together into a 3D cube, boom, you've got a higher dimensional tensor. It just scales up, exactly like physical blocks. And let's look at how friendly the actual code is. If you want to create a simple vector tensor, you literally just type x equals torch.tensor and hand it your numbers, like 1, 2, 3, 4, 5. If you ask PyTorch to print its shape, it'll just pop out and tell you it has 5 elements in one single dimension. It is so straightforward and so readable. This simplicity right here is exactly why developers are obsessed with it. Look at that. You're already reading deep learning code. All right, let's keep the momentum going. Section 4, Building and Training Networks. To actually build an AI network, we just snap these layers together. Here's a beautifully isolated little snippet of code that does exactly that. We use nn.sequential to tell PyTorch, hey, stack these layers in this exact order. We kick things off with a linear layer that takes 2 inputs and expands them out to 8 hidden connections. Then we pass that data through nn.relu. That's an activation function. Just think of it as a bouncer at a club deciding which signals are strong enough to let through. Finally, another linear layer funnels those 8 connections back down into one single output. The data just flows right on through, left to right. Okay, so the network is built. Now we actually have to teach it. We do this using a training loop, which is basically our instruction manual. First up, the model makes a prediction. And spoiler alert, it's probably going to be totally wrong at first. So step 2, we calculate loss. That just mathematically measures exactly how wrong that prediction was. Step 3, PyTorch uses this brilliant trick called automatic differentiation to calculate gradients. It's basically figuring out exactly which specific knobs and dials inside the model need to be tweaked. Step 4, we update those parameters. And then we repeat. We do this whole loop over and over, thousands of times, until the model finally gets it right. Now for the final stretch. Section 5, Acceleration and Summary. Look, when you start messing with millions of high-res images or just mountains of text, your standard computer processor is going to start choking. It's just too slow. That is exactly where GPU acceleration comes into play. By using graphics processing units, the exact same chips built to run high-end video games, PyTorch can massively, and I mean massively, speed up those huge tensor computations. Fun fact for you, heavy lifting tasks that used to take literally months on a standard processor, with a GPU, they can take just a few hours. So if tensors are a raw lumber, GPUs are the heavy-duty power tools of our workshop. As you keep diving into this, you're going to run into a few helpful built-in tools over and over. Torch.optimum is where you'll find the optimizers. Those are what automatically adjust your model's parameters during that training loop. Dataset and data loader are absolute lifesavers. They help you bundle up massive amounts of raw data and feed it into your model in nice, manageable chunks. And Torch Vision, that's this amazing add-on packed with pre-built datasets and tools specifically for computer vision. I just wanted to plant these seeds right now so you'll be like, oh, I know that when you see them later. Now, before we wrap up, as your mentor, I've got to warn you about a few common potholes. Literally everyone makes these mistakes at first. The absolute most common one is confusing tensor shapes. It's like trying to smash a square peg into a round hole. It just won't compute. Another big one is a device mismatch. That's when you accidentally leave your data sitting on your CPU, but you put your model on your GPU. They literally cannot talk to each other across that divide. Also, keep an eye out for forgetting to switch between your training and evaluation modes, picking a bad learning rate, or just feeding messy, unnormalized data into your network. Keep these in the back of your mind, and I promise you will save yourself hours of pulling your hair out. Just to quickly zoom out, let's contextualize where PyTorch actually fits into the broader Python universe. If you're busy preparing and cleaning up your raw data, you're probably going to be using libraries like NumPy or Pandas. When you want to visualize that data and draw beautiful charts, you'll reach for Matplotlib or Seaborn. But when it is finally time to actually build and train complex neural networks, that is exactly when PyTorch steps into the spotlight. It's a highly specialized tool for a highly specialized job. All right, let's summarize the whole shebang. What did we learn today? PyTorch is a hugely flexible, open-source framework completely focused on deep learning. It uses these neat little containers called tensors to process all our numerical data. It hands us the perfect building blocks to quickly construct neural networks. It has this magical built-in automatic differentiation to handle all the brutal math of training for us. And it fully supports GPU acceleration to do all of this at lightning speed. So you've learned the workflow, you've seen the raw materials, you understand the logic behind the loop. You have officially unlocked the door to the workshop. The only question left is this: Are you ready to take your very next practical coding step and build your first simple neural network? The tools are right there, waiting for you. Dive in, start playing around, and let's see what you can build.